Okay, here's a short astronomy video on altitude and azimuth, and then declination or right ascension. You can actually see I'm doing this on October 4th, 2016. Looks like it's 21 minutes after 8 o'clock at night. I'm looking south. What I'm going to do first is throw on the azimuth grid, and if you take a look at numbers, this is +5 because 0 is sitting right here on the equator. Can't really see the 0 line, but there's the +5, the +10, the 15. It's going up in units of 5 all the way up to your zenith, which is the point directly above your head. So altitude is the distance above the equator, or above the horizon, all the way up to 90 degrees. Okay, these are what are called the azimuth directions, and they actually start to the north. So I'm going to go all the way to the north, and there's your 0 degrees. And it goes 10, 20, 30, 40, moves in a clockwise direction, so it goes towards the east. And the east is found at 90. We go to southeast, which would actually be located halfway in between 90 and 180. And then we go to south, which is the 180 direction. We can go to southwest, okay, the point directly halfway in between. We go to west, which is 270, and all the way back to north, which is 360, or back to 0. So this is the way we talk about in just normal sky without knowing anything else. How high is it above the horizon? And then how far west of north is it? And what the heck is that thing? There's a satellite. Because shouldn't be anything moving at this speed. So if you're looking north right now, you can actually see a satellite moving through the sky. Okay, so that is the azimuth grid. Now I'm going to show up the equatorial grid, and the equatorial grid will start with north again. That's really weird seeing this thing that looks like the size of Capella actually moving in reference to all the other things in the sky. Actually a pretty good click, probably traveling about 17,000 miles an hour. But if you notice, Polaris, the North Star, is almost at the North Celestial Pole. If you look at degrees, we have 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90 degrees up. And then if we get rid of the Earth, we can see that we go down 45, 40, 35, all the way down to 0, which is located right there, and that is the celestial equator. So now we're actually talking about degrees north and south of the celestial equator. So this is the north celestial hemisphere, this is the south celestial hemisphere. And if we go down to the south celestial pole, you notice there's no star, but it still is 90, actually minus 90 degrees of declination. And then we have what are called right ascension, and if you take a look at the lines, you can see we actually go up to 24, and then we start up at 0, and then we go to 1. It's actually showing 15 degrees of arc, and this is how far the celestial sphere actually moves in an hour, and it moves this direction because the Earth really is going that way. But anyway, 1 hour later, this is going to be located there, and if I actually put some speed into it, you can see it's actually moving, and it moves in that direction. Then we have 2, 3, 4, 5, 6, and 6 actually makes the point of a quarter of the way around. And then we go to, if we actually start at 0, and we go all the way over, we should actually have 12 right there. And then we have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 hours of rotation, because the Earth actually rotates around this direction in a day. So that's the difference between right ascension and azimuth, and declination and altitude. Okay, that's it. Thank you. Actually, I want to go to north again. I want to see if that satellite is still up there. And it should actually be up there somewhere, unless it actually got out of the reference of the sun. And I'm not seeing the satellite anymore. Looks like it's gone. Okay, that's it. Bye.